If fx and gx are polynomials, the function fx over gx is called a rational function. We already knew how to add two rational functions. For example, 2 over 3x plus 1 over x plus 1. The denominator is the product of the two denominators, 3x plus 1 times x plus 1. We cross-multiply the numerator and the denominator. And the sum's numerator is 2x plus 2 plus 3x plus 1. Therefore, the result is 5x plus 3 over 3x plus 1 times x plus 1. This is also a rational function. The reverse process, or writing a rational function as the sum of other rational functions, is called expressing the rational function in partial fractions. We'll learn how to do partial fractions for three types of denominator. The first type is ax plus b times cx plus d times ex plus f. If the denominator is in this form, then the function can be expressed as capital A over ax plus b, plus capital B over cx plus d, plus capital C over ex plus f. Let's look at an example. Express 2x squared plus 17x plus 21 over x plus 2 times x plus 3 times x minus 3 in partial fractions. The denominator is a product of three linear polynomials. So we can express it as a over x plus 2, plus b over x plus 3, plus c over x minus 3. Now let's combine these three functions. The denominator is the product of the three linear polynomials. The numerator is a times x plus 3 times x minus 3, plus b times x plus 2 times x minus 3, plus c times x plus 2 times x plus 3. The numerators are equal. Therefore, 2x squared plus 17x plus 21 is a times x plus 3 times x minus 3, plus b times x plus 2 times x minus 3, plus c times x plus 2 times x plus 3. We can find a, b and c in two ways. The first is to use substitutions. The right-hand side has several products of linear polynomials. We put in values that make those factors 0. Let x equal 3. The left side is 2 times 3 squared plus 17 times 3 plus 21. Let's look at the right side. The first and second terms both have x minus 3, so they become 0, and only the term with c is left. This is c times 3 plus 2 times 3 plus 3. So 30c is 90. Therefore c is 3. Let x equal minus 3. The left side is 2 times minus 3 squared plus 17 times minus 3 plus 21. On the right side, the first and third terms are 0, and only the term with b is left. It is b times minus 3 plus 2 times minus 3 minus 3. So 6b is minus 12, and b is minus 2. Let x equal minus 2. The left side is 2 times minus 2 squared plus 17 times minus 2 plus 21. The right side is a times minus 2 plus 3 times minus 2 minus 3. This is minus 5a equals minus 5. So a is 1. Therefore, the partial fractions are 1 over x plus 2, minus 2 over x plus 3 over x minus 3. The second way to find a, b and c is equating the coefficients. Let's multiply out the right-hand side and collect like terms. It is a times x squared minus 9, plus b times x squared minus x minus 6, plus c times x squared plus 5x plus 6. It is equal to ax squared minus 9a plus bx squared minus bx minus 6b plus cx squared plus 5cx plus 6c. Collect like terms. It becomes a plus b plus cx squared, plus 5c minus bx, plus 6c minus 6b minus 9a. Equating the coefficients, we get a plus b plus c equals 2. 5c minus b equals 17. 6c minus 6b minus 9a equals 21. Solving these three simultaneous equations, we get a is 1, b is minus 2, and c is 3. We get the same result. You can see this approach is usually more complicated than substitutions. Therefore, we prefer substitutions. but you are free to use whichever approach you feel comfortable with. The second type of denominator is ax plus b times cx plus d squared. The function can be expressed as capital A over ax plus b, plus capital B over cx plus d, plus capital C over cx plus d squared. Express 3x squared plus 6x plus 2 over 2x plus 3 times x plus 1 squared in partial fractions. We can write it as a over 2x plus 3, plus b over x plus 1, plus c over x plus 1 squared. Combine these three. The denominator is the same, which is 2x plus 3 times x plus 1 squared. And the numerator is 8 times x plus 1 squared, plus b times 2x plus 3 times x plus 1, plus c times 2x plus 3. The two numerators should be equal. We use substitution method. Let x equal -1. The first and second terms become 0. So 3 times -1 squared plus 6 times -1 plus 2 equals c times 2 times -1 plus 3. Therefore, c is -1. Let x equals -3 over 2. The second and third terms become 0. So 3 times -3 over 2 squared plus 6 times -3 over 2 plus 2 equals a times -3 over 2 plus 1 squared. Therefore, a is -1. Here we have only two unique factors, and we've already used both values that can make them 0. How do we find the third value? We can just use a random value that makes our calculation easy. Let x equal 0. Then 2 equals a plus 3b plus 3c. Put in the values of a and c, we get -1 plus 3b minus 3. Therefore, b is 2. You can also find a, b and c by equating the coefficients. We will not illustrate it here. The third type of denominator is ax plus b times cx squared plus d. It can be expressed as capital A over ax plus b, plus capital B x plus capital C over cx squared plus d. Express 4x plus 6 over x minus 1 times x squared plus 9 in partial fractions. We can write it as a over x minus 1 plus bx plus c over x squared plus 9. Add the two fractions. The numerator is ax squared plus 9 plus bx plus c times x minus 1. The two numerators should be equal. Let x equal 1. 4 plus 6 is 10a. So a is 1. 1 is the only value that can make the factors 0. So we'll pick two other random values. Let x equal 0, we get 6 equals 9a minus c. Put in the value of a, we get c as 3. Let x equal -1. 2 equals 10a plus c minus b times -2. Put in the values of a and c, we get b as -1. In this class, we learned a rational function can be expressed in partial fractions. If the denominator is ax plus b times cx plus d times ex plus f, it can be expressed as capital A over ax plus b, plus capital B over cx plus d, plus capital C over ex plus f. If the denominator is ax plus b times cx plus d squared, it can be expressed as capital A over ax plus b, plus capital B over cx plus d, plus capital C over cx plus d squared. If the denominator is ax plus b times cx squared plus d, it can be expressed as capital A over ax plus b, plus capital B x plus capital C over cx squared plus d. A, b, and c can be found by substitution or equating the coefficients.